Hello guys, welcome back to my tutorial. So in this tutorial we're going to look at measures of central tendency. We'll look at the theory of mean, and then we'll begin to code. Okay, so central tendency helps you to find the middle, the average of a given data set, right? This measures that indicates the values in the distribution fall under. What values the distribution measures indicates the most values in the distribution, and what these values fall under. It also refers to as central location of the distribution. So whenever we're talking about central tendency, we are basically talking about three most commonly used parts, so measurement. So there's a mean, there's a median, and then there's a mode. So in this tutorial we'll cover mean, and then the next we'll cover median and mode. So we'll cover mean in this tutorial. So what mean is? Mean is also commonly known as the arithmetic mean, or some people on the street can be called average, right? So it's just the same thing. So to find an average, you find the sum of all the values divided by the total number of values. So for example, if you want to find the average of this value, we simply add all up these values and then we divide it by the total number of values in here. So we'll add 1 to 3, 5 plus 7 plus 3 plus 2 all the way to 23, and then you divide it by the total numbers within this data set, which is 1 2 3 4 5 6 7 8 9. So we divide that value by 9. So we divide the sum of all these values by 9, and that's how we get mean. So mean is commonly denoted by x bar. So x, and then there's a bar on top of it, that is called x bar. So there are two types of mean, the symbols for mean. They can be sample mean, which is just calculated from the sample, denoted by x bar. Then there is the population mean, which is denoted the mean for the whole population, denoted by the Greek letter mu, which is just this. Okay, so now let's try to see how we can calculate a mean in Python, right? To use Python libraries to calculate mean. So I'll just open up my terminal, navigate to where your virtual environment is, the statistics folder, and make sure you have your virtual environment activated. You can see mine is activated here. Okay, so if you don't know how to activate, you can watch the right video, the last tutorial, the first tutorial, and then if you're using Windows, you can refer that video which I suggested to you guys. Okay, so now that I'll just go ahead and actually open Jupyter. So now I'll just go open Jupyter Notebook like this, and then I'll press enter. This will go and actually open Jupyter Notebook for us. So let's wait for it to open up. It will open up at localhost, and then this port 889. Okay, so in the last row we created this, right? So let's just go ahead and actually create a new one and call it mean. So create a new IPython notebook. So we'll call it we're just going to call it mean. So I'm just going to call it mean, and then we save that. So we're going to import two libraries. We're going to one library other. We're going to import this numpy. So we're just going to import numpy as np. So in Python, this numpy library is a library that is written by other people and provides us a lot of functionality. In the last tutorial, the first tutorial, we learned how to install it. So now we're just bringing it into our application to use it. So we're telling Python, hey, bring in this library, we want to use it. So we're importing numpy as np. So we're importing it as np, so you don't have to type numpy all the time. So you just have to type in this code. So now we have that library imported. This is what you call, this is how we import libraries in Python. So now that you have imported library, you can say np dot, let's call it data, and then we say np dot range. Let's call it a range. It's called a range. So this is just a method, the method that comes with pandas, that will generate random values between a certain range. So we want to generate numbers starting from 20 to 200, right? And then we want what is the step that you want. So we want, say, let's say we want what is the step, maybe to generate 20, and then how many steps should this keep? Maybe you should generate 20 and then 25 and then 30, like that. So we have to specify the steps, right? So I'll just leave the steps to be 20. Okay, so have the 20 between our data. The steps will be 20. So I run this code. Just press shift and enter on your keyboard, or you can simply select the cell just by clicking on the cell and then pressing the run button. So again, here we can do data, and then we can run the cell. So you can see we have this data set, which is just called an array, a numpy array. Okay, so in Python we have also something known as a list. So it's a list, and then you can just do this, and then in here you can store data. We can just do 2 3 4 5 6, like just like this. So and then we can do a list. I call it a list, and then run this, and then we can see we have a list in Python. Now these are two different things. A numpy array is much faster than a Python list, because a numpy array is written in C, and C is faster than Python. So that's why I'm using a numpy array for faster computation. So if you want, most of the time what you'll be doing as a data scientist, you'll be working a huge amount of data, you want that speed, so always use a numpy array rather than a Python list. because Python list computation is very expensive, because Python lists are actually objects, right? Okay, so now that you have done that, I can just do data dot mean, just like this, and then I can run this cell. So it's going to return to me the mean of these values, right? The average of these values. That's how you can find the average of these values. So all these values, if you add them up divided by the length of this value, you can get 100. So let me just do it again. Do data dot sum. Sum return to us. Let's just store it in here. Call it sum, and then we'll store it in here. So we are going to get the sum, and then we can print out the sum. So this return to us the sum of this value. So and now let's look at the length of data. So we look at the length of data, and the length of the data, just say length, just stands for length, and then you pass in the data frame, the data array that you created. You pass in here, it returns to you how many elements are inside of here. So 1 2 3 4 5 6 7 8 9. So you have 9 elements within that thing. So to get that, you just pass in length, and then to get the sum, you just do the data frame dot sum. It returns to you the sum. So now if you take the sum divided by let me just call this length like this, and then yeah, run this cell. So I'll pass in here, and I'll pass in length like this, and then I run it. You can see we got 100. So we got the same value as before. So we just found the sum divided by the length of data, so we get the mean. So to do it in a shorter way, we just have to say df dot mean, just like this, and then you get the mean of the data. So that's all we do to calculate the mean in Python. So that's how we can calculate the mean in Python. So let's continue with our tutorial, and then let's look at other variations of mean there is. So we have variations of mean. So that we have the weighted mean. So weighted mean is the sum of the product of the values multiplied the corresponding weights divided by the weights, the sum of the weights. So that's how the formula is. Okay, so there is a line here. This is a fraction. When I go into presentation mode, it doesn't show it, but whenever I quit the presentation mode, you can see we have that line there. So we take the weights times the values of the in the data set divided by the weights of that data set. So let me just show you what I mean by that. It might be a bit tricky to understand. So let's take an example of a school system, right? So in a school, maybe you have a test, a quiz, final exam, and homeworks. All these might have weights, right? Maybe the final exam has more weights than the test and the quizzes. So these are the categories, these are the weights, and this is what the students score. Let's take one student. So the test weights 20%. So we take this times 20%, we put it in a list, we write it down, and then we take the quiz, we take 50, which has a weight of 15. So we take 15 times 80, write the value down, and then we take 40 times this, write the value down, 25 times this, write the value down. So we add up all the values we get from multiplying this, all of these corresponding elements, right? So after we have that value, we need to now to divide it by the sum of the weights. So this plus this plus this plus this, we divide it by the sum of the products of these corresponding elements. That's how you calculate weighted mean. Okay, so this, you can see this will be over 100, right? So now let's see how we can calculate weighted mean in Pandas. So let's generate let's call it score, generate a random numbers, which we just call np.arrange. Let's say the students score numbers grades. Let's just let's create a normal array, so we can learn a new method. So we can call it array. So this another way we can create an array in Numpy. So anyway, we need to pass in a Python list. We've already discussed list just a few minutes ago. So let's say the student got let's just copy these values in here. So the student got 20, 15, oh sorry, 75, 80, 98. So 75, wait, 78. Okay, so 78, 80, 98, and what else? 98 and 98 and 89. So 89. So 89. So these are the scores of the student. Now let's calculate the weights. So you need weights, and then in here you need to pass in weights. We need to create another numpy array. So called numpy.array, and then you need to pass in a Python list. So let's look at the weights of these marks. So the weights are 20, 15, 40. 20, 15, 40, and 25, I believe. So 20, 15, so 20, 15, 40, 25, right? So these are the ways. So just run this, and then we have that there. So now let's go ahead and actually calculate the weighted mean. So you can just do np.average, right? To calculate the weighted mean in using Numpy, we say average. It's a bit confusing because mean and average in the kind of normal on the streets kind of mean the same, but in here they're different. So you just press shift and tab on your keyboard, and then you can see the documentation. So you need to pass in an array of the scores, and then you also need to pass in weights. Okay, so there's also something known as axis. We won't talk about axis for now. So we just pass in the score of the students, and then followed by the weight. So you need to pass in score, and then you need to say that weights. Let me just is just weight. So yeah, weights equals to weight. So run the cell, so you can find that they have the weighted average of the weighted mean of the student is actually an 88.5. so that's roughly about 89. So if you calculate the actual mean of the student and the weighted mean, there's a difference, right? So that's a variation of the mean. Okay, and then also have something known as the trimmed mean. So if you have a trimmed mean, for example, let's say, let me just bring you back here, we have this array, right? These numbers, right? Let's just go back up here. Let's use this one because it's much detail. Let's say we have these numbers, and then you have to calculate a trimmed mean. And then what trimmed mean does is that you remove some numbers from both ends, some values from both ends. So we want to calculate the mean, the trimmed mean, by removing two values from both ends. So what you do is that you remove two values from this end, and then you remove two values from this end. The remaining result, you find the mean of it. Okay, so let me just show you what I mean by that. So I can just say data. Let's just print the data here so we can have it here. So I want to remove the 20 from 2 from this side and 2 values from this side, and then I'll find the mean of the remaining. That will be our trimmed mean. So I just go data equals to data, and I want to move from this. We start in Python, we start counting from 0 based indexing. So this will be 0, this will be 1, this will be 2 and 3. So we start from 0. So this is 1, 2. So we want to start from 3. So in here we put in 3, and then 3, 2, and then we want to remove the last. So we just have to say the length of this minus 2, right? So we want to say this is 1, 2. We start from, so go 1, 2, 3, 4, 5 to 5. Then we run that, and you can go data, and you can see we have only 2 values. So why this happened is that we need to start from 2, right? My bad. So this is actually 0, 1, 2, right? Starting from 2, and then you're going until 2. This is 0, 1, 2, 3, 4, 5, 6, right? 6. So we put in here 7 because the last number is ignored. So we put in here 7. Sorry, this is 7, and then we can run the cell. So we have an empty array, so I don't know why we're having that. So let me just check this out. Let me go 6, then do data. I'm still getting an error, so let me just try to run all this. Let me just try to run the whole cell again. Yeah, we have that values there. Sometimes Numpy really gives back me this, so just putting a 7, and then I need to run all of this again. So run all of this. Yeah, we have that value. So we have 60, 80, 100, 120 and 40, right? After removing 2 values from both ends and removing 2 values from both ends. So we have these values, and now we want to find the mean of this value. So if you find the mean of this value, that will be the trimmed mean of the dataset dot mean. So now this is how trimmed mean is all about, and we go to 100. So let me just run all of this again. Sometimes I don't know if that's the actual mean. Yeah, so maybe this is the actual mean, so I can't really tell. The best thing sometimes to do is just to give it a different name so that you can avoid that kind of conflict sometimes. So I hope that we didn't the Numpy really understood. I mean, we didn't make any errors, and the actual value for this is 100. So you can just actually type this into your calculator just to confirm. So this will be 60 plus 80 plus 100 plus 120 and then plus 140. So you run this, and then you divide it by how many elements are in there. So 1, 2, 3, 4, 5. Then you divide it by 5, and then the answer is 100. So the trimmed mean of this value after removing 2 values from both ends is actually 100, and Numpy is correct. So we are correct on that. So that's how trimmed mean works in how we can calculate trimmed mean. Okay, so the first thing that we are going to do first is that we actually scale the first thing we do is that we need to have the data sorted. So you can come back here, you can see that our data was actually sorted, and then after sorting our data, we can drop the values from equal values from both ends, and we drop two values from both ends. Then we calculate the mean as we normally did. So this is how we can calculate trimmed mean in pandas, using pandas. So this is the formula for trimmed mean. So again, there is a line here, so let me just exit the presentation mode so you guys can see that line. So it's just this is the formula for trimmed mean, and this the values to remove from both ends. So this is the formula. So you can actually write a program to calculate that for you. This is very complex. I saw this online and it's really a bit complex, so I didn't want us to dive into complicated stuff right now because some of us are still new to Python, right? So yeah, that's all I wanted us to discuss in this tutorial. So in the next tutorial, we'll probably look at median, and then look at median and mode, right? And then go into variance and standard deviation and stuff like that. So thanks for watching. If you find it helpful, again, please kindly like this video, subscribe to this channel, hit the notification bell for more videos like this. Thanks for watching. Keep safe. Please don't forget to like this video, and if you like this video, drop a comment in the comment section why you like this video. If you hate this video, give it a thumbs down and leave a comment in the comment section to why you hate the video, and give any feedback on what I'm doing wrong and how I can improve on this set of series that you're doing. Thank you guys very much. Please kindly hit the subscribe button and give this video a thumbs up. Thanks for watching. Keep safe.